Mila, let us do number systems. I will start from the beginning. In our number system, we've got natural numbers, and the reason why they are called natural numbers is because it is natural to count from 1 up to a number close to infinity. Basically, it's actually even easier to count from, especially when you're counting objects. And that's why natural numbers are also called counting numbers. Now, when natural numbers came into existence, there was something that was missing. There was a number that was missing. We couldn't determine a numerical value for nothing. Okay, so we had to come up with a numerical value that we can use to specify nothing, to specify something that is not there at all. And that is why we came up with a whole new set of numbers, which we call natural numbers. I mean, whole numbers. The reason why we call them whole numbers is because we put a whole in natural numbers. We put 0 into the natural numbers, and that gave birth to whole numbers. Whole numbers are basically just your natural numbers. You just add 0 to them. And still, when we had whole numbers, there was something missing. How do we determine negative values, like your negative temperature, where your temperature is below 0? How do we find a number reduced or reduction of a number? And hence they came up with what we call integers. Please note that under this set of numbers, we do not have decimals. Okay, there are no decimal fractions. There are no fractions. It is just your whole numbers plus negative natural numbers. And I need you to understand something here. When we look at negative numbers, okay, obviously they will continue up to a certain number. When we look at negative numbers, a number that is closest to 0 is the biggest. Now, if I have negative 2 million, right? What this simply means is that, and I'm given, let's say, negative 2. Which number is actually bigger here? Please note that negative 2 is the one that is closest to 0. Negative 2 million is somewhere far left. It's on the far left. And because it is furthest from 0, it is the lowest. Only when we look at negative numbers, we will specify that a number that is closest to 0 will be the biggest. A number that is furthest from 0 will be the smallest, only for negative numbers. But when you look at positive numbers, please note that a number that is furthest from 0 is actually the biggest. So in this case, if I was to have 2 million, obviously here that is bigger than that. Let's say I have negative 10, or let me just put it this way. Let's not say it's negative 10. Let me say it's positive 10 and I've got positive 100. Which one is bigger here? I think this is quite easy. That positive 100 will be bigger because it is the furthest from 0. And then we've got a whole new set of numbers which couldn't determine part of the whole because we divide as people, we share things. And for sharing things, there was no numerical value for that. Hence, we needed to come up with a new set of numbers which we call rational numbers. Now, rational numbers are basically, there's 3 conditions that must be met for a number to be a rational number. Now, for a number to be a rational number, it is either it should be a fraction, If it is not a fraction, it must be a finite decimal. If it's not a finite decimal, it should be a recurring decimal. Now, these are three conditions that must be met. For you to specify a number as a rational number, firstly, it must be a fraction. If it's not a fraction, it must be a finite decimal. If it's not a finite decimal, it must be a recurring decimal. So not all actually should be met. Only one should be met of the three conditions. So it's either a number that you're given is a fraction. If it is not a fraction, it must be a finite decimal. If it is not a finite decimal, it should be a recurring decimal. Fractions, what are they exactly? A fraction is just a part of a whole. It is just a part of a whole, where the denominator determines the number of parts we are dividing a whole by. Therefore, please note that the numerator can be any integer. The numerator can be any integer. By integers, I mean natural numbers and negative natural numbers. That is a numerator. Your numerator, by saying it can be an integer, please note that when we deal with integers, there is zero. So zero can also be in the numerator. However, a denominator can be any integer except for zero. I repeat, the denominator can be any integer except for zero. And I repeated it again. The denominator cannot be equal to zero. The denominator cannot be equal to zero. However, the numerator can be any integer. And as I've said, the denominator can be any integer except for zero. And these will be your examples of rational numbers. As I've said, rational numbers will be divided into fractions. So when you talk about fractions, it'll be 3 over 2 in those examples that you given there. It'll be 3 over 2. And for a finite decimal, it will be something like negative 1,8. So this is a finite. It means that decimal stops after a certain point. In this case, immediately in the first decimal, that's where it stops. It can be first decimal, third decimal, fourth decimal. When it stops, we call it a finite decimal. And infinite decimal just goes on and on and on. Okay. And then we've got the recurring decimal. A recurring decimal will be a number like 0,7 with a dot on top. So when you have 0,7 with that dot at the top, on top of 7, we can write this as 0,7777777. Okay, what if I've got 2,15 and let's say 1,8 because now it decided to be 8 and I've got dot on top of 1 and 8. So when we write that, it'll be 2,18. So it means 1,8 is repeating itself. 1,8, it's repeating itself. 1,8, and it goes on and on and on. Now I can close the class in lab. I even closed the door. So they decided to bunk my lesson. I'm gonna I must do that, ne? I'm not kidding. I don't think you did that. No, there's no homework. There's no homework at all. Irrational numbers are basically all the numbers that do not meet the above number sets. Basically, these are numbers that we cannot express as a fraction. They are infinite and they are not recurring. Basically, it's all the numbers that are not rational. We basically cannot calculate them as fractions or have a numerator or denominator. And they also include non-recurring decimals. And these are examples of such numbers. Pi is part of irrational numbers. Then we have real numbers. Whenever I ask students as to what real numbers are, they will normally say to me, it's numbers that are real. And that's not the answer that I'm looking for. Real numbers are all sets of numbers. It's basically start from the natural numbers, whole numbers, integers, rational, irrational. All number sets fall under real numbers. These are numbers that you can punch into your calculator and get a value for. And here are examples of those real numbers. Then we have non-real numbers. Obviously, these are numbers that are not in the above specified number sets. They are not real. They do not form part of any number set done thus far. This will be something like the square root of a negative number or an even root of any negative number. It can be the sixth root. We can say it is the sixth root of, let's say, negative 25. Okay. The sixth root of negative 25. As long as your root is even, and inside that even root you have a negative number, then that number is not a real number. Now, you might make a mistake by thinking that the cube root of negative 8 is not real, but actually it is real because the cube root of negative 8 is negative 2. Actually, it's even more than real. It's also an integer. Be careful, be very, very careful when you're doing such. Don't just look underneath the root and think that the answer is not real. It'll only not be real if you're finding an even root. Okay, I hope that makes sense. And basically, this is just a summary of everything that I've spoken about. Try this class or give yourself 8 minutes. Now, for the first one, we have negative 2 over 3, which is a fraction. And just because it is a fraction, we cannot say it is a natural number because we don't have fractions under natural numbers. We don't have fractions under whole numbers. We don't have fractions under integers. However, we do have fractions under rational numbers. And because it is rational, it will not be irrational. It will actually be a real number. Let's go to the second one. 0 is not a natural number. It is, however, a whole number. It is an integer. We can also write it as a fraction by writing it as 0 over 1, which is 0. And because it ticks any of those boxes, it'll also be a real number. 0.3 with a dot at the top, that will be written as 0.3333333. And because it is a decimal, it does not fall under natural whole numbers and integers. Instead, it will fall under rational numbers as a recurring decimal. It will also be a real number. What about the square root of 27? The square root of 27 will give us 5,196,152,423, which is not a finite decimal, it's not a recurring decimal. Therefore, that is actually irrational. And because it is irrational, it will also be a real number. Square root of 4 divided by square root of 9. It will be 2 over 3. 2 over 3 is a fraction. It is not a natural number. It is not a whole number. It is not an integer. It is a rational number, and it is also a real number. Cube root of 8, I just did it with you not long ago. Well, actually, it's different here because this cube root of 8 will give us 2. Cube root of 8 is 2. 2 is a natural number, it's a whole number, it's an integer, it's also rational and real. Negative 1.7 is just a rational number. It is a finite decimal, and finite decimals fall under rational numbers. And because it is rational, it will also be real. 111 is all of the number sets except for irrational numbers. Let us look at the properties of 1 and 0. We normally refer to them as identity elements. Identity element of addition is 0, and that is because any number that you add with 0 will be any number. Okay, meaning that if I take 4 and I add it with 0, I will get 4. If I take 5 and I add it with 0, I will get 5. If I take 10 and I add it with 0, I will get 10. If I take negative 16 and I add it with 0, I will still get negative 16. An identical value as the one that I added. That is why whatever number you add with 0, it'll give you whatever number. That is why we say 0 is an additive identity. And what do you think will be the multiplicative identity? So I want you to tell me a number that I can multiply with another number and I will still get another number. Okay, by another number, I mean that specific number. If I take 5, I'm multiplying with this number, I will still get 5. If I take 10 and I multiply with this number, I will still get 10. Which number will that be? That number will be 1. That is why we say 1 is the identity element of multiplication, when you take 1 and you multiply by a number, your answer would be that specific number. And here are examples. 5 multiplied by 1 will still give you 5. 10 multiplied by 1 will still give you 10. Inverses. Basically, we will deal with additive inverses. An additive inverse is basically a number that you add with its additive inverse will give you 0. I want you to tell me which number can I add with 2 and get 0. 2 plus negative 2 will give me 0. So we say the additive inverse of 2 is negative 2. The additive inverse of 5 is negative 5. The additive inverse of 100 is negative 100. An additive inverse of negative 7 will be positive 7. The additive inverse of negative 11 will be 11. Here, I wanted the additive inverse of negative 3. The additive inverse of, the additive inverse of 3. The additive inverse of 3 will be negative 3. That is because when you take 3 and you add it with negative 3, your answer will be 0. Now, what is the additive inverse of 4? The additive inverse of 4 is negative 4. And what is the additive inverse of negative 8? The additive inverse of negative 8 is 8. Let's look at multiplicative inverse. You are basically looking at a reciprocal of a number. How do you do that? You take that number, you express it as a fraction, and you swap its numerator and denominator. And the answer that you get will be what we call the multiplicative inverse or the reciprocal. Look at this. The multiplicative inverse of 5, what is it? You first have to write 5 as a fraction, so I am going to divide it by 1. And then swap the numerator and the denominator. And this will give us how much? 1 over 5. So we say the reciprocal of 5 is 1 over 5. What is the reciprocal of 6 over 7? Swap these two. And the reciprocal will be 7 over 6. This is very important for when you get to varsity, by the way. Now, how do I prove that 7 over 6 is the reciprocal of 6 over 7? When I take 6 over 7 and I multiply it with 7 over 6, I should get 1. Remember, when you multiply fractions, you multiply the numerator with the numerator and the denominator with the denominator. How much will that be? Six times 7 is 42. In the denominator, 7 times 6 will be 42. And 42 divided by 42 is 1. Similarly there, 5 over 1 multiplied by 1 over 5, we will get 5 over 5. Which is just 1. I just did this for you. What is that? What is the reciprocal or multiplicative inverse of 2 over 3?
Well, they're not professional. When I tell Val they're not professional, I called them twice. When I asked if they are professional, they don't give me the right answer. They just hang up the call. So I'm gonna call some important person. And then Standard Park has a dictionary drain, Oxford Dictionary, yesiZulu, Malkiona, or Standard Park, PNA, I think, 200 rand.
Hey, Malit. I was looking for the house now. It's no longer on the market. I wonder what's going on. The answer to this will be 3 over 2. Let's look at other properties. Commutative property simply says that the arrangement of addition does not matter. So the way the numbers are added really doesn't matter. If I have m plus n, it'll still give me the same answer as when I take n and I add it with m. Now, 3 plus 7 will give you the same answer as 7 plus 3. Both of them will give you 10. Now, what is the commutative property of a plus b? It is b plus a. What about the commutative property of 2 plus 3? The operation will be 3 plus 2, which gives you 5. Let us look at the associative property. Associative property says that you can, when you add numbers, you can group them differently, but you will still get the same answer. For example, let's group this in 3 different ways and see if we will get the same answer. I can start by adding 5 and 4, then add 1. 5 plus 4 will give me 9. 9 plus 1 will give me 10. Or I can group it this way. I can group 4 and 1. 4 plus 1 will give me 5. 5 plus 5 will give me 10. What's the last grouping? Correct, it is 5 plus 1. 5 plus 1 is 6. When you add it with 4, it'll give you 10. Got it? Try this classwork. Please note that the grouping also works for multiplication. It doesn't matter how you group products, actually factors, when you multiply, you will still get the same product. Try this one to prove it. Okay, here are the solutions. Here you can group 4 and 3. 4 times 3 will give you 12. 12 times 7 will give you 84. I thought this was complex. I prefer this one here because it's quite easy. 3 times 7 is 21. 21 times 4, because you're not carrying anything, it'll give you 84. Or you can group 4 and 7, which is 28 times 3, it'll give you 84. All right, let's check the distributive property. To distribute means that the outside vector must be multiplied by all terms or sums or differences of numbers inside the bracket. And basically, let me just give you an example and then it will make sense. When I have two factors here, because you know that brackets mean multiplication, it means the outside factor. This is the first factor. The second factor will be this whole bracket. When I break this bracket, I will multiply 5 by 2 and then multiply 5 by 3, but I will keep the sign in between, which is the plus. So this will be the same as 5 times 2 plus 5 times 3, which is 10 plus 15. And 10 plus 15 will be 25. Now, I gave my students something like this. How would we multiply this? And I asked one of my students who gave me this answer here to multiply this. It's better for you to break that to 98 into hundreds, which will be 200. And then the tens, which will be 90. Then the units, which will be 8. And then you distribute. So this is better, especially when you're trying to multiply in your head without using a calculator. I prefer to do it this way because you get to the answer way quicker than using this in your mind and trying to solve it without writing anything down. So you can use this table here. You did this in grade 3, I think. Okay, you can use this table, but the problem with this table, you have to apply it. You have to do all the calculations in your mind and you can't make mistakes. I normally use this one when I'm teaching because I want answers now. I don't want to think about the whole process. So this one is quite easy because I just break it down and multiply in my head and just add. Quick. Even though someone can say the other one is quicker than this method, but I feel like this one is quicker. This is like grade 1-ish math, which is quite quicker to me. Now, when you multiply, you will start by multiplying this. It'll give you 400. Then multiply 2 with 90. It'll give you 180. And multiply 2 with 8. It'll give you 16. So these two here will give you 580. You just add it with 16. And it will give you 5, 9, 6. So that's why distributive property can help you. That's why sometimes you need to break things apart and to make it easier for you. Okay. All right, let's try this one out. Multiply this with that. Multiply this with that. This is what you would have. So remember, you multiply 11 with 100, you keep the minus in between, then you multiply 11 with 80. 11 times 100 will give you 1,100, and then you keep the minus. 11 times 80 will give you 880. And 1,100 minus 880 will give you 220. Try this classwork. Give yourself 2 minutes. And this is the solution. 2 minutes again. You will get the solution. And that's it. All right, let's get to factors because I need to give you guys homework. I realize that the videos that I've sent actually didn't have any sound. You can actually look at them, however, they don't have sound. That's why I had to record another video. Now, what are factors? Factors are simply numbers or terms multiplied to get the given product. Now, if I'm given 10, to find the factors of 10, I'll just divide by 10, 10 by any divisible natural number. I'll start with 1. 1 divided by 10 will give you 10. So my factors will be 1 and 10. So when I take 10 times 1, it'll give me 10. And then I'll take the second natural number, which is 2. 2, you will take it and divide 10 by the 2. 10 divided by 2 will be 5. So it means that my factors will be 2 and 5. 2 times 5 should give you 10. So here I will have all of those 4 as my factors, which is 1, 2, 5, as well as 10. You will write it as F10 is equals to 1, 2, 5, and 10. Okay. Interesting. I did this in class and then it's still here. Anyway, to find the factors of 20, I'll do the same thing. Take all your natural numbers that can get into 20 without leaving any remainders. And that will be 1 divided by 20, it will give you 20. So 1 multiplied by 20 will give you 20. I'll try 2. 10 divided by 20 divided by 2 will give you 10. That means my factors will be 2 and 10. And then 20 divided by 3 doesn't work. 20 divided by 4, it does work. 20 divided by 4, it's 5. So my factors there will be 4 times 5, which is 20. So when I write my factors here, it will be 1, 2, 4, 5, 10, and 20. And I showed you there with the arrows as to how it works. So 2 times 10 will give you 20, 1 times 20 will give you 20, and 4 times 5 will give you 20. That's how I found those factors. However, guys, please note that these workings are actually not necessary. So if I ask you to find factors, I just expect you to give me the answer in this form. You got it? Good. Try this. And may I please have this tomorrow? Okay, so this will be your homework for everyone, including the swimmers. Just take a couple of minutes to watch this video. And can I have this tomorrow in your books, please? Okay, I just cannot afford to waste any day. I am really, really sorry. I have to make sure that you learn some math every day because yes, we really need those good math results in metric. Just can't afford to lose any day. Sorry you had to watch a video for this. Okay, see you guys tomorrow. If you don't understand, please don't forget to ask questions. You can email me or you can send me a voice note. It is totally up to you. All right?